Miss Morrison, the other day I had my kids at the park and my son was swinging on the swings. It made me think of pendulums. Do you know what a pendulum is?
It's funny that you should ask. I've actually been studying pendulums lately. A swing is a perfect example of a pendulum. It is any mass that is attached to a fixed point and can swing freely. So a swing's a perfect example. It's attached at the bar and it can swing freely. You're the mass when you sit on your swing. Can you guys think of more pendulums that you see in your day-to-day life?
Wouldn't an arm inside a grandfather clock be a pendulum that ticks-tocks back and forth and swings?
Yes, that is a pendulum. Also, a wrecking ball is a pendulum. It's attached to the crane and then it swings back and forth, crashing into buildings. I actually have built a pendulum right here. We have a fixed point, an arm, and a bob. Right where the string is attached to a pencil is our fixed point. It's attached. The arm extends all the way down to our little penny, which is a bob. And if I hold this out and release, it swings totally freely. When we're doing science, we like to change things and make observations. And if we wanted to change something, first we have to have a starting place. We have to establish a standard. What do we want this pendulum to look like? What do you think our standard should be for this pendulum?
Well, I've actually thought about it, and the standard that we're going to use for this pendulum is as follows. We're going to have a length of 38 centimeters. So if I measure from the fixed point at the top the whole way down to the bottom of my bob, I have a distance of 38 centimeters. The bob at the end is going to be a penny. Our point of release is going to be 90 degrees. So I'm going to make sure that I'm holding this straight out, level with the tabletop, so I don't want to pull too hard or have slack in my string. I want it to be nice and straight. And when I release, I'm going to make sure I simply let go. I don't want to push it because I can't control that. We're going to set the timer for 15 seconds, and we're going to count a cycle as one complete back and forth motion. So if I release this, that would be 1, 2, 3, etc. Okay? And that will establish our standard then. We all would be doing the same thing.
Okay. How many cycles do you think we would actually get in 15 seconds?
Let's make a prediction. This is our awkward pause moment, right?
Yeah,
Okay.
say now. That's true.
Okay. All right, so now you take that. We're going to edit all that out. All right, now that we've made a prediction, let's test to see if we're correct. So a reminder, a cycle is one complete back and forth swing. So it's going to come out and go back to you. I'm going to set the timer for 15 seconds, and you folks at home are going to count along with us.
We're going to count every time it comes back to me.
Ready, set, go.
Right, if you got 12, that is correct. It was almost 13, but remember, a cycle is all the way out and all the way back. So we got 12 cycles in 15 seconds. We're going to add that to our standard. Every time we have this length and this bob and this point of release and this time, we should get 12 cycles every time.
Now that we've established our standard, we're ready to explore through scientific inquiry by changing something. So what could we change about our standard pendulum that we could then observe or measure to see if it has an effect?
Maybe we could try changing the bob. Right now it's a penny. We could try a smaller dime or maybe a quarter.
We could also change the point of release. So instead of releasing it at 90 degrees, we could hold the pendulum up higher or maybe lower.
I like that idea. We could also try to change the length of the pendulum, the length of the arm. We could try a really long string or maybe a really short string and see if that makes a difference.
I think that's a great idea. Let's go with that one. So how now do we state a testable question that we can investigate?
That's a good question. You guys are going to go find the answer to that. There's an interactive, smart, sweet lesson for you. You're going to go explore the 2 important pieces of a testable question. Good luck.